Ever deployed an app to Kubernetes and it just, well, acts weird?
Mm-hmm.
Like maybe it looks like it's running, but no traffic gets through.
Right.
It just keeps restarting. Or maybe, poof, it's gone.
Yeah, that sounds familiar to a lot of people, I think.
Understanding why that happens and how Kubernetes itself tries to handle it, that's just so crucial.
Absolutely.
And that's exactly what we're going to unpack today. We're doing a deep dive into, well, the basic journey an app takes in Kubernetes, the pod lifecycle, and its really important restart policies.
Right.
We're using some great material called Kubernetes pod lifecycle and restart policies as our guide here.
And look, this isn't just abstract theory. It's, about getting real control over your applications when they're actually running in production.
Right.
So whether you're trying to figure out why a deployment is stuck, or maybe designing a new microservice to be resilient, or even just trying to make sense of kubectl to get pods.
Which we all do.
Exactly. Getting a solid handle on the pod lifecycle and how these restart policies fit together, that's really your foundation for predictability, for stability.
Okay.
It's how you make sure your apps don't just run, but they can, recover smartly when things inevitably go wrong.
So let's quickly define terms. At the heart of it all is the pod, right?
Mm-hmm.
Smallest thing you can deploy in Kubernetes. Holds one or more containers, that's your actual app code.
Yep, the basic unit.
And the pod lifecycle. That's just the story of that pod, from creation to, well, end of life.
Yeah.
And how Kubernetes manages it.
Precisely. It describes all those stages, and our mission today, really, is to break down those phases a pod goes through.
Okay.
And maybe even more critical, how Kubernetes steps in when a container inside that pod fails. Understanding that interaction is key to keeping things available.
Right, even when things get bumpy.
Exactly.
Before we jump into the phases, maybe just a super quick refresher on some core ideas, just for context.
Good idea. So you've got the cluster, that's the whole set of machines managed by Kubernetes.
Got it.
Those machines are called nodes, could be physical, could be virtual. They're what actually host your pods.
Okay. Nodes host pods.
Inside the pods are your containers. Lightweight things running your app.
Right. Docker containers usually, or something similar.
Yep. And then there's the kubelet. That's the agent running on each node. It manages the pods on that specific node and reports back their status. Super important.
Kubelet on the node. Okay.
And finally, kubectl. That's the command line tool you use to talk to the cluster, tell it what to do, ask it what's going on.
Perfect. Okay. Foundation's laid. So let's get into this journey a pod takes. These phases you mentioned, you actually see them when you run kubectl, get pods right.
Exactly. That output isn't just random text. Each phase tells a story. It's a critical clue.
So what's the first one we usually see?
Often, it's pending. This means, okay, the pod's been created, the API server knows about it, but it's not actually running on a node yet.
Then why would that be? Is something wrong?
Not necessarily wrong, but it needs investigation. Maybe the scheduler is still figuring out which node to put it on. More commonly, though, it could be resource constraints.
Like not enough CPU or memory available anywhere.
Exactly. Or it could be waiting for container images to download if you have a huge image, or maybe network issues to the registry.
It'll just sit there in pending.
It'll sit in pending until that image pull completes. Like, say, pulling a big Nginx image could take time.
Okay, so pending isn't always bad, but it means not ready yet. What's next?
Hopefully it moves quickly to running. This is the state you generally want to see. Pods assigned to a node, all its containers are up, and, well, running.
And this is where the kubelet is active.
Very active. The kubelet on that node is now monitoring the pod, running any health checks you've configured, those liveness and readiness probes, making sure the app isn't just on, but actually healthy and ready for traffic.
Like a web server pod serving requests that's running.
Perfect example. That's the ideal state for most long-lived applications.
Okay, what about pods that aren't meant to run forever? Like a batch job?
Good question. That leads us to the succeeded phase. This is for tasks that have a defined end.
So it finished its job successfully.
Exactly. All containers in the pod completed their work without errors, exit code 0, and crucially, they won't be restarted. Think of a pod that processes a data file, finishes, and exits cleanly. It goes to succeeded. Done.
Makes sense. So what's the opposite of that?
That would be the failed phase. This means at least one container in the pod terminated with an error, specifically a non-zero exit code.
Okay, so something went wrong inside the container.
Right, maybe a configuration error, a bug in the code, something caused it to crash. And here's the important bit. A pod in the failed state won't be restarted unless its restart policy says otherwise.
We'll get to restart policies soon, I bet.
We will, but failed is your big red flag. Check your application logs, something's broken.
Got it. Are there any other phases?
There's one more, but it's pretty rare. Unknown.
Unknown, like Kubernetes just shrugs.
Sort of. It means the state of the pod can't be determined. This usually points to a communication problem between the kubelet on the node and the main Kubernetes control plane.
So not the app's fault necessarily, more like network trouble.
Exactly. Maybe the node itself became unreachable. The kubelet just can't report back. So less about your app, more about the underlying infrastructure potentially having issues.
Okay, so summarizing that flow. You create a pod, it starts as pending,
While it gets scheduled and images pull,
then moves to running, doing its job.
monitored by the kubelet,
And then, depending on what it is and what happens, it ends up as either succeeded or failed.
or rarely unknown if the node goes offline. Yep, that's the basic journey.
And knowing these phases is key for troubleshooting, right? Like pending could mean cluster resources.
Or image pull issues.
Failed means look at your app logs.
Definitely. Each phase guides your debugging.
Okay, this is where it gets really interesting for me. What happens when a container inside that running pod just fails, crashes? That's where restart policies come in, isn't it? This feels core to Kubernetes resilience.
Absolutely core. Restart policies define exactly how Kubernetes, specifically the kubelet on the node, should react when a container within a pod terminates. They work hand in hand with the lifecycle phases.
And you set these up in the pod's definition, like in the YAML file.
Precisely. Under spec.restart policy, there are three main options.
Okay, what's the first one?
The first, and importantly the default one, is always.
Always restart.
Always restart. If a container fails, crashes, exits with non-zero code, the kubelet automatically restarts it.
That sounds like what you'd want for, say, a web server or an API.
Exactly. It's ideal for long-running services where you want Kubernetes to try and keep it alive automatically. If your Nginx container hits a weird temporary glitch and crashes, always brings it right back.
What if it keeps crashing, like a persistent bug?
That's a crucial point. Always can sometimes hide a deeper problem. If you see a pod constantly restarting, maybe in a state called crash loop backoff, the always policy is working, but it's telling you your application has a recurring fatal issue you need to fix. It's not a magic bullet for bad code.
Right. It tries its best, but eventually you need to fix the root cause. Okay, what's the next policy?
Next up is OnFailure.
Only restart on failure.
You got it. Containers are restarted only if they terminate with a non-zero exit code, a failure. If they complete successfully, exit code 0, they are not restarted.
When would you use that?
Think about tasks that might fail occasionally but are worth retrying. Maybe some kinds of batch processing jobs. If a job processing a file hits a temporary network blip and fails.
OnFailure tells the kubelet to give it another shot.
Exactly. But, and this is important architecturally, if you use OnFailure, your application really needs to be idempotent.
Idempotent, meaning it can run multiple times safely.
Yes. Running the same task again shouldn't cause bad side effects, like creating duplicate records or sending the same notification twice, because OnFailure will retry it if it fails. You have to design for that.
That's a key design consideration then.
Yeah.
Okay, always on failure. What's the last one?
The last one is straightforward. Never.
Never restart.
At all.
Never. Doesn't matter if the container succeeds or fails. Once it stops, it stops. The kubelet won't touch it again.
When would that make sense?
For tasks that should absolutely run only once, maybe a setup script or a job performing a very specific, delicate operation where a retry would be harmful or just plain wrong.
Like a one-shot initialization task.
Perfect example. You run it, it does its thing, successfully or not, and it's done. Never ensures it stays done.
So, always for services, OnFailure for retryable tasks, never for one-shot deals. That covered a lot of ground.
It does. And the kubelet enforces these rules, ultimately leading the pod towards that succeeded or failed phase if restarts aren't happening or the task finishes. This paints a clearer picture. So how does this all connect back to the bigger Kubernetes system? You mentioned the kubelet, the API server. How do they coordinate this whole life cycle and restart dance?
Yeah, it's a neat, coordinated process. It really starts when you, the user, submit that pod definition, usually with kubectl play.
Okay, I send my YAML file.
That request hits the Kubernetes API server. The API server validates it and stores the desired state in etc., which is Kubernetes central database. That's step 1. Pod creation is recorded.
Got it. Desired state is saved.
Then, the scheduler component notices this new pod that needs a home. It looks at all the nodes, considers resource requirements, constraints, etc., and picks the best node for the pod.
Assigning it a place to live.
Right. It updates the pod's definition in etc. with the chosen node name. This is part of moving it out of that pending state.
Okay, scheduled. Now the node needs to actually run it.
Exactly. Now the kubelet on the assigned node sees, hey, this pod is supposed to run here.
Ah, the kubelet wakes up.
It reads the pod spec, talks to the container runtime, like Docker or containered, to pull the necessary images if they aren't already local, and then starts the containers defined in the pod. This is execution.
And the pod enters the running phase.
Hopefully. Hopefully. And once it's running, the kubelet doesn't just walk away. It constantly monitors the containers. Are they still running? Are they passing their liveness and readiness probes?
Checking their health.
Constantly. Now, if during this monitoring a container dies, the kubelet immediately checks that pod's restart policy. This triggers the restart handling.
So it looks up always, on failure, never.
Yep. And based on that policy and the container's exit code, it either restarts the container or leaves it terminated.
Okay, makes sense.
And all through this creation, running, failing, restarting the kubelet is performing status reporting. It keeps telling the API server, here's the current phase of this pod, here are the container statuses.
Which is how we see the phase change when we run kubelet pods.
Exactly. That command just asks the API server for the latest status reported by the kubelet.
Cool. And then finally, how do pods end?
Termination. This can happen a couple of ways. You can manually delete a pod with kubectl delete.
The explicit kill command.
Or, for pods not designed to run forever, like those using never or OnFailure policies or jobs, they can terminate naturally once their work is done, or they hit a failure state they won't recover from. The kubelet cleans up the resources.
Wow. Okay. That ties it all together nicely. From user request to the kubelet managing it on the node and reporting back.
It's a really robust feedback loop.
Let's try and walk through a full example just to lock it in. Say I have my simple Nginx web server pod, and I definitely want it to stay up, so I set restart policy.
Always.
Okay, good choice for a web server.
I run kubelet apply-f web-pod.yam.
All right, API server gets it, stores it in, etc. Scheduler sees it, finds a suitable node, let's call it node 1, and assigns the pod there.
Okay, assigned to node 1.
The kubelet on node 1 sees the assignment. It pulls the Nginx image, if needed, starts the Nginx container. And my pod status changes too. Running.
Running. You check kubectl get pods, it shows running, everything seems fine, your website is up.
Perfect. But then, maybe hours later, there's a temporary glitch. I don't know, a weird request. Causes Nginx to crash. Non-zero exit code.
Okay. The kubelet on node 1 immediately detects that container termination and the error code.
And it checks the policy. Sees always.
Sees always.
Yeah.
So it doesn't just mark the pod as failed. Instead, it immediately starts the Nginx container again.
Does the pod phase change briefly, or does it stay running?
Good question. Internally, the container restarts. You might see a restarts count increment if you watch kubectl get pods, but the overall pod phase should likely remain running because Kubernetes successfully brought the container back online according to policy. It healed itself.
Ah, okay. So the service might have a tiny blip, but the pod itself remains in the running phase because the policy worked.
Exactly. Now, you should still investigate why it crashed, right? You'd use ubectlog's webpod to see the Nginx errors.
Right. Check the logs to fix the underlying cause.
But the key is that always policy kept your service available during that time. The self-healing kicked in.
You can really see how understanding these phases and policies gives you the power to, well, monitor what's happening, debug when it goes wrong, and actually design your deployments for better reliability.
Absolutely, it's fundamental. So, just to wrap the core ideas, you've got the pod lifecycle phases, pending, running, succeeded, failed, and the rare unknown. They map the pod's journey and give you those diagnostic clues.
Check.
And working right alongside them are the restart policies, always, OnFailure, never. They dictate how the kubelet automatically responds to container failures, providing that built-in resilience.
Got it.
And for you, listening, really getting these concepts down isn't just, academic. It's essential if you want to build and manage robust, scalable applications that can actually handle the real world.
It really provides a solid framework. So thinking about this, given how pods are designed to be pretty ephemeral, right? They can be created, destroyed, restarted. They aren't permanent fixtures.
Definitely not. Treat them as cattle, not pets, as the saying goes.
Exactly. So what implications does this whole life cycle, this potential for restarts and transients, have for how you should design your applications? Not just the deployment YAML, but the actual code, especially around things like managing application state or how services find each other.
That's a fantastic question to ponder.
It feels like a fundamental shift, doesn't it?
Yeah.
Once you grasp these Kubernetes mechanics, it really changes how you approach building resilient cloud-native apps from the ground up.